Again, we need to find the derivative of implicit function. We need to separate dy over dx, given x plus tangent of xy equals 0. So plan for that is to separate tangent xy equals negative x. And we plan to find the derivative of left side and right side. Let's do that. Derivative of the whole function here, tangent. Derivative of tangent, as we know, is secant square. Secant square xy. Secant square and whatever it has, this function. And then go deeply inside, apply chain rule, and find the derivative of xy. Derivative of xy will be u dash, that's the derivative of inside, u dash v plus uv dash. So it will be derivative of x, which is 1 times y, it's y, plus u, which is x, times derivative of v, which is dy over dx. That's the derivative of inside. So derivative of tangent will be secant square times derivative inside will be y plus x dy over dx equals derivative of negative x is negative 1. And remember, our target here is to separate dy over dx. So let's divide both sides by secant square xy. So y plus x dy over dx equals negative 1 divided by secant square xy. And I guess you know what is the inverse of secant square? Reciprocal of secant, it will be what? I hear you, cosine. Then 1 over secant square will be cosine square. Cosine square of xy. And you have negative here. Again, 1 over secant square is cosine square of xy. And you have negative sign here. Equals x y plus x dy over dx. Second step, I need to eliminate y. So subtract y from both sides. Subtract y. So x dy over dx, subtract y, will be negative cosine square xy minus y. Finally, you're going to divide both sides by x. So separate dy over dx by dividing by x will be negative cosine square of xy minus y divided by x. And this is the final answer.